Hello students, welcome to mathematics class. Today's topic is ratio and proportion. In this session, we will learn about ratio. Introduction to ratio. Children, in our daily life, we often make different comparisons. For example, Ramesh is taller than Harish. Anu's weight is less than her sister's weight. Cost of a car is more than the cost of a scooter. In this example, two quantities of the same type are being compared. Like, height of Ramesh is being compared with the height of Harish. Weight of Anu is being compared with the weight of her sister. Cost of a car is compared with the cost of a scooter. The two quantities are of same type. Car and a scooter both are the type of vehicle. And the cost of car and scooter are being compared. Hence, we compare quantities in terms of magnitude and measurements. There are two ways of comparing two quantities. Comparison by difference, comparison by division. When we compare any two quantities, by finding the difference between them, this is known as comparison by difference. When we compare any two quantities by finding how many times one quantity is of other, this is known as comparison by division. Let us know better with another example. Suppose your mother brought 15 pencils. She gave 10 pencils to you and 5 to your younger sister. It means, how many pencils do you get more than your sister? You get 5 pencils more. How to find? You subtract 5 from 10. 10 minus 5 gives 5. Here, to compare the number of pencils given to you and your sister, the difference between yours and your sister's share was found. This process is known as comparing by difference. Children, there is another way of comparing the pencil share in this example. You can also find that you got 2 times more pencils than your sister. That is, 10 divided 5 equal to 2. Here comparison has been done by division. So, we conclude that you got 2 times more pencils than your sister. You got pencils 2 times more than your sister. Hence, when you compare two quantities by division in terms of how many times, then this comparison is known as comparing by division. To understand better, let us take another example. Suppose we want to compare the number of hours spent on studies by Reena and Prachi. Reena spent 5 hours on her studies. Prachi studies for 7 hours. So, if we say that Prachi studies 2 hours more than Reena, then we have done comparison by difference. But if we say Prachi spends 7 by 5 of what Reena spends on studies, or we say that ratio of number of hours spent by Prachi on the studies to that of Reena is 7:5. This is comparison by the method of division. Hence, ratio of two quantities in the same unit is the fraction of one quantity is that of the other. As you can see, both the quantities have same unit, hours. Hence, ratio of A is to B is written as A by B. Remember children, every ratio can be expressed in the form of a fraction as A is to B equal to A by B, where A and B are the two terms of the ratio. The first term A is known as antecedent and the second term B is known as consequent of the ratio A is to B. The symbol of ratio is colon. Some points to remember about ratio. Point 1. Ratio exists between two quantities of the same kind. As we have learned from this example, we can compare any two quantities if it is of same kind. Here we are comparing the number of hours spent on studies by Reena and Prachi, and both have same unit, hours. Hence, we can compare easily by division process. To find ratio of two quantities, we need to ensure that they are expressed in the same units. Remember children, when you are comparing any two quantities, make sure that both the quantities have same unit. As in this example, both the quantities are expressed in hours. Then only it is easy for us to compare the number of hours spent on studies both by Reena and Prachi. Ratio being a fraction has no units. As you can see in this example, 7 hours is to 5 hours equal to 7 by 5. We express ratio in the form of fraction, and remember, ratio has no unit. A ratio does not change if its both the terms are divided by or multiplied by a non-zero number. That means, when in a ratio the terms are multiplied or divided by any number, then the value of the ratio does not change. For example, 7 by 5. When 7 by 5 or 7 is to 5 is multiplied by 2 to both the terms of the ratio, we get 14 is to 10. 7 is to 5 and 14 is to 10 have same value. If terms of ratio are changed, then A is to B is not equal to B is to A. For example, 3 is to 4 is not equal to 4 is to 3. Remember, if the terms in the ratio is changed, then the value also gets changed. Some terms related to ratio. Simplest form of a ratio. What is the simplest form of a ratio? A ratio A is to B is said to be in simplest form if the HCF of A is to B is 1. It is similar as the process of finding the simplest form of a fraction. To reduce a ratio A is to B in simplest form, we divide each of its terms by HCF of A and B. For example, find the simplest form of 15 is to 20. To find the simplest form of the ratio 15 is to 20, first express in the form of fraction. 15 is to 20 equal to 15 by 20. Now use the similar process as we have used to find the simplest form of a fraction. Find the HCF of both the terms 15 and 20. The HCF of 15 and 20 is 5. Now divide 5 to both the numerator and the denominator. 15 divide 5 whole by 20 divide 5. It gives 3 by 4. Again check what is the HCF of 3 and 4. HCF of 3 and 4 is 1. That means the ratio 15 is to 20 is in its simplest form. Hence, the simplest form of 15 is to 20 is 3 is to 4. Remember children, It is same as the process of finding the simplest form of a fraction or reducing the fraction into its lowest term. Find the simplest form of a ratio until the HCF of both the terms of the ratio is 1. Equivalent ratios. Two ratios that have the same value are called equivalent ratios. For example, 1:2 is equal to 2:4. Both the ratios have the same value. 1:2 and 2:4. 2:4 when reduced to lowest term, it is equal to 1:2. Hence we can say that both the ratios 1:2 and 2:4 has the same value. Hence the two ratios can be called as equivalent ratios. To find the equivalent ratios, multiply or divide both the terms by the same number. It is same as the process of finding the equivalent fractions. For example, Reena is 32 years old and her son is 4 years old. The ratio of Reena's age to her son's age is 32:4, which is equal to 8:1. The HCF of 32 and 4 is 4. Hence we get 32:4 equal to 8:1. So the ratios 32:4 and 8:1 are called the equivalent ratios. Practice time. Let us solve few sums related to ratio. Example 1. Find the ratio of the following. Question A. 36 minutes to 2 hours. Children, to find the ratio between two quantities, it must have same unit. As we can see in this question, both the quantities have different unit, minutes and hours. So we need to convert hours into minutes or minutes into hours, so that both the quantities would have same unit. 36 minutes to 2 hours. To find the given ratio, we convert 2 hours to minutes. Since 1 hour equal to 60 minutes, so 2 hours equal to 2 into 60 minutes. So 36 minutes is to 2 hour equal to 36 is to 2 into 60. Now convert this ratio into fraction. 36 whole divided by 2 into 60. After solving, we would get as 3/10. Hence our required ratio is 3:10. Question B. 200 rupees to rupees 75. In question B, you can see both the quantities have same unit as rupees. Hence we can find the ratio as rupees 200 to rupees 75 equal to 200 by 75. Convert the ratio into fraction. Now find the simplest form of 200 by 75. You know that HCF of 275 is 25. Hence, divide 25 to both numerator and denominator. 200 divide 25, whole divide by 75 divide 25. We get 8/3. Hence, the required ratio is 8:3. Question C. 2 meter to 35 cm. Convert meter to centimeter. Since 1 meter equal to 100 cm, 2 meter equal to 200 cm. So 2 meter to 35 cm equal to 200 centimeter is to 35 cm. Now convert this ratio into fraction. 200 cm to 35 cm equal to 200 by 35. Find the simplest form of 200 by 35. HCF of 235 is 5. So divide 5 to both numerator and denominator. We get 200 divide 5 whole divided by 35 divide 5 equal to 40 by 7. Hence our required ratio is 40:7. Question D. 4 liter to 250 ml. Convert liter to ml. Since 1 liter equal to 1000 ml, so 4 liter equal to 4000 ml. 4 liter is to 250 ml equal to 4000 to 250. Now convert this ratio as fraction. 4000 is to 250 equal to 4000 by 250. 0 gets cancelled. We have 400 by 25. Now find the simplest form of 400 by 25. HCF of 425 is 25. So divide 25 to both numerator and denominator as 400 divide 25 whole divided by 25 divide 25. We get 16 by 1. Hence our required ratio is 16:1. 90 cm to 1.5 meter. In question E, both the quantities have different units. So, convert 1.5 meter to centimeter. So, our required ratio is 90 cm by 1.5 meter equal to 90 cm by 1.5 into 100 cm, which gives 90 by 150. 0 gets cancelled. We have 9 by 15. Find the simplest form of 9 by 15. HCF of 9 and 15 is 3. So divide both numerator and denominator by 3. 9 divide 3 whole by 15 divide 3 gives 3 by 5. Hence our required ratio is 3:5. Question F. 5 meter to 100 cm. Convert 5 meter to cm. So our required ratio is 5 meter by 100 cm equal to 5 into 100 cm whole divided by 100 cm, which is equal to 500 by 100. 0 gets cancelled in numerator and denominator. We get 5 by 1. Hence our required ratio is 5:1. Question G. 2 dozen is to 4 score. As we know, the value of 1 dozen is equal to 12. So 2 dozen equal to 2 into 12 gives 24. The value of 1 score equal to 20. So 4 score equal to 4 into 20 equal to 80. So 2 dozen is to 2 score equal to 24 by 80. Find the simplest form of 24 by 80. The HCF of 24 and 80 is 8. So divide 8 to both the numerator and denominator as 24 divide 8 whole divided by 80 divide 8. It gives 3 by 10. Hence our required ratio is 3:10. Remember children, in order to find the ratio, we need to ensure that both the quantities must have the same unit. Example 2. The number of boys and girls in a school are 1450 and 1050. Express the ratio of the number of boys to the number of girls. In order to solve the sum, first write the statements. Write the given information. Number of boys equal to 1450. Number of girls equal to 1050. Total number of students equal to 1450 plus 1050. It gives 2500. Now solve each question. Question A. The number of boys to the number of girls. The ratio of boys to the girls equal to 1450 is to 1050, which is equal to 1450 by 1050. 0 gets cancelled. We have 145 by 105. Now find the simplest form of 145 by 105. The HCF of 145 and 105 is 5. So divide 5 to both numerator and denominator as 145 divide 5 whole divided by 1005 divide 5. which gives 29 by 21. So the ratio of boys to girls is 29 is to 21. Question B. Ratio of the boys to the total number of students equal to 1450 whole divided by 2500. Find the simplest form of 1450 and 2500. The HCF of 1450 and 2500 is 5 and we get 29 by 50. Hence the ratio of boys to the total number of students equal to 29 is to 50. Question C. Ratio of the number of girls to the number of boys, which is equal to 1050 by 1450. Find the simplest form of 1050 and 1450, which gives 21 by 29. Hence the ratio of number of girls to the number of boys equal to 21 is to 29. Question D. Ratio of number of girls to the total number of students, which is equal to 1050 divided by 2500. 0 gets cancelled. We get 1005 by 250. Find the simplest form of 1005 and 1005 divide 250. HCF of 1005 and 250 is 5. So divide both numerator and denominator by 5. As 1005 divide 5 whole divided by 250 divide 5, which gives 21 by 50. Hence the ratio of the number of girls to the total number of students is 21 is to 50. Let us solve few more word problems. Example 3. Rohit earns 12,000 rupees per month. He saves 3,550 rupees per month from his earning. Find the ratio of question A, his saving to his income. To solve this word problem, first find the given fact. Rohit's income is 12,000 rupees per month. Rohit's saving is 3,550 rupees per month. So the ratio of his saving to his income equal to 3,550 whole divided by 12,000. 0 gets cancelled. We have 355 whole divided by 1200. Now find the simplest form of 355 divided by 1200. HCF of 355 and 1200 is 5. So divide both numerator and denominator by 5. As 355 divide 5 whole divided by 1200 divide 5, we get 71 by 240. Hence the ratio of his saving to his income is 71 is to 240. Question B. Find the ratio of his saving to his expenditure. Expenditure means money spent. Money spent by Rohit. Formula to find the expenditure is income minus saving. So expenditure of Rohit equal to 12,000 rupees minus 3,550 rupees. We get 8,450 rupees. So the ratio of saving to expenditure equal to 3,050 rupees whole divided by 8,450 rupees. Rupees gets cancelled. 0 gets cancelled. Now we have 355 whole divided by 845. Now find the simplest form of 355 by 845. The HCF of 355 and 845 is 5. So divide 5 to both numerator and denominator. As 355 divide 5 whole divided by 845 divide 5. We get 71 by 169. Hence the ratio of saving to his expenditure is 71 is to 169. Question C. Find the ratio of his expenditure to his income. Ratio of his expenditure to his income equal to rupees 8,450 450 whole divided by rupees 12,000. Rupees gets cancelled, 0 gets cancelled. We have 845 whole divided by 1200. Find the simplest form of 845 divided by 1200. HCF of 845 and 1200 is 5. So divide 5 to both numerator and denominator. As 845 divide 5 whole divided by 1200 divide 5. We get 169 divide 240. Hence the ratio of his expenditure to his income is 169 is to 240. Example 4. A car travels 90 km in 3 hours and a train travels 200 km in 2 hours. Find the ratio of their speeds. From the given question, we could know that distance travelled by the car is 90 km and time taken to travel this distance is 3 hours. So, we can calculate the speed of the car by using the formula speed equal to distance by time. So, speed of the car equal to 90 divide 3. 90 km divided by 3 hour, which is equal to 30 km per hour. Remember children, speed is represented by kilometer per hour. Then, distance travelled by train is 200 km. Time taken to travel this distance by train is 2 hours. So, speed of the train can be calculated by the formula distance by time, which is equal to 200 km by 2 hours, which gives 100 km per hour. Now find the ratio of their speeds. Ratio of car is to train equal to 30 by 100. 0 gets cancelled, we get 3 by 10. Hence, ratio of their speeds is 3 is to 10. In this way, we can solve what problems related to ratio. Example 5. Divide rupees 600 among Rehana and Rashmi in the ratio of 2 is to 3. Our total amount is 600 rupees. We need to divide 600 rupees among Rehana and Rashmi in the ratio of 2 is to 3. In order to do so, first find the total part. The total part is 2 plus 3 equal to 5. So what is Rehana's share? Out of 5, Rehana would get only 2 part. What is Rashmi's share? Out of 5, Rashmi would get only 3 part. So let us find their individual share. Rehana's share equal to 2 by 5 of rupees 600, which is equal to 2 by 5 multiplied by rupees 600. After solving, we would get rupees 240. So Rehana's share equal to rupees 240. Rashmi's share. Rashmi's share equal to 3 by 5 of rupees 600, which gives rupees 360. Hence, Rashmi's share equal to rupees 360. Example 6. Two numbers are in the ratio of 3 to 7 and the sum of the numbers is 810. Find the numbers. From the above question, we could know that the ratio of the numbers are given to us, that is 3 to 7. We don't know the exact numbers. Sum of the two numbers is 810. We need to find the numbers. As ratio of the numbers are given to us, hence the total part is 3 plus 7 equal to 10. Now easily we can find the first number as first number equal to 3 by 10 of 810, which gives 243. Second number equal to 7 by 10 of 810, which gives 567. Hence, our numbers are 243 and 567. Hope you have understood the concept. Thank you.